Welcome, Erik. I think are you still on mute somehow? Let me see.
Yes, here I am. Thank you, Stefan.
Yeah, welcome. I already said that you have such a professional equipment. How does that come?
I lost my mouse on the second screen.
Okay. What a pity. And I remember last time you have your bicycle behind you, so you're riding the bike a lot of time, yes?
Yes, if I have time, I can go for a ride, and even during this Corona crisis, it's still possible. I'm very happy with that.
But it's just because you're in a rural area, right? It's not in the city.
No, actually, in Belgium, people are still able to ride their bike, and
yes?
Only by two, and they have to keep 1.5 meter distance, and that's it.
With the bikes, okay.
Yes.
Oh, yeah, interesting. I think we're going to hear more of that from each other today. So when you posted that, what was basically the reason why? What is it all about? What we're talking about today?
Well, actually, as you told, we are confronted with this crisis, and we start thinking, how can we do something about it? How can we help solving this problem and fighting this virus? And then actually, it's Jonathan who came up with the idea, and he sent me a WhatsApp. Maybe we should join forces and do something about it. And then I said, okay, let me sleep about it. And the next day, the project was launched, actually. So,
cool.
Yeah, we took action pretty quick. And I can tell you it took a lot of our time and energy to start it. But I really was amazed how much people we could engage within short time and how people are motivated to collaborate and join us in this project.
Yeah. So the project's name is actually Imaging COVID-19 AI Initiative, right?
Yes, that's correct.
And so since we have Ángel here and Jonathan here, so we both joined us in the company's the initiative to work on that project. Is that correct?
Yes, that's correct. They are the partners who joined us. Maybe I can say them if you allow them to say a few words themselves.
I'm Jonathan. I'm the founder of Robovision, and we apply AI at scale. And in this, on a Saturday 2 weeks ago, I called Erik. I said, "This is the ideal option to apply AI because we need data at scale in the form of many CT scans."
Yeah, so that's an issue. The data issue as always, right? Okay. And so how did you came into the group?
Well, actually, that's obviously Erik and me share, the participation and position in the board of the European Society of Medical Imaging Informatics, where Erik is the president, and we know each other. And basically, we had some customers in Italy, and we realized so quick what was the pandemic going on there. So in February 14, we already launched a post in our blog stating about this concern, and at that time no one was taking care in Spain about. So we started to develop a kind of CT AI module, and we put that open in March 14, and that was that Saturday that we all three met. And well, we met on Monday, I think, but on Saturday we released that version in web, and we leave that open for science and research purposes. And then we scaled it up to this consortium and this collaboration. No? So we are happy on that growth. And as Erik was mentioning, it have been many different conversations back and forth till we are here. Yeah.
Yeah. So where are you based? You're based in Spain, right?
I'm based in the east of Spain, in Valencia.
Uh-huh.
And right now I'm not in the city. I'm in the north, hometown, close to my parents. But in lockdown, it's better to have some garden.
Yeah, sure, definitely, I believe that. So Spain has been hit also very hard.
Yes.
So that's at least from the news. So I'm really sorry to hear that, and it's really sorry to follow up on the news here. So stay safe with your team and your family.
Yeah, thank you. Yes.
And Jonathan, where are you based?
I'm at this moment based in my office in Ghent, but I live in Antwerp. But here in Ghent, it's very quiet. I have a large garden, so everything is fine here.
Oh, lucky guy. So you have gardens, and Erik has a garden as well, or not?
Yes, yes.
Yeah.
Yes, I do have a garden, yeah.
Fantastic. Okay, so I would like to hand over to you, Erik. So you're as the president of the European Society of Medical Imaging Informatics. I have even the website here open. Share my screen again. This is the society, right? So this
Yes,
is the
exactly.
name of the society.
Yes.
Can you a little bit tell us about what you're doing here? What is it all about?
Yes, so we are kind of, we are a society that is affiliated with the European Society of Radiology, which is at this moment actually the biggest radiological society in the world. They have more than 100,000, I think more than 150,000 members from all over the world. But we are actually a bit particular in the sense that we, with our society, we focus on imaging informatics in radiology, and imaging informatics for the reason that radiology has changed over the past few decades, and all the information that we're using now is mainly digital. So this also means that we can do a lot with this material. And so I will explain this in my lecture, but this is also why we are making a shift from let's say rather morphological interpretation of images to a digital analysis of images and using this digital information. And so our society is trying to inform radiologists about the value of using this information and how to do it. We try to teach them, we give lectures to and training to residents, to young radiologists, to learn them how to deal with this information and how the digital data are flowing, and how what kind of methods we should use to, let's say, standardize the information that we have and that we can share, etc. So that's a very broad topic. And so we not only have radiologists in our society, but also computer scientists and clinical physicists, for example, and technical physicians, yes. So, I mean, it's a mixture of people, and we try to exchange knowledge and expertise, and let's say, try to combine this to find interesting solutions that can be used by radiologists.
Interesting. So you're a radiologist by profession?
Yes, I am a radiologist. I'm medically trained, and I do have a full-time position as a radiologist, yes.
So in your talk, what are you going to talk about?
In my talk, I'm going to explain what is happening with radiology in the COVID crisis. So what kind of imaging are we doing, and why are we doing it? And in what sense could artificial intelligence help us, and how could it be of value, and what should we think about, and what should we take care about? And then I also would like to explain what we are doing with our project. So what brought us to this, to starting with this.
Okay, awesome. Sounds great. So just start, Erik. I'm really listening to it.
Okay.
I'm going to, guys, I'm going to ask you a short question. Before we start, I would like to know what you're actually working in. Are you a radiologist, a data scientist? What are you? You can even say more or two things so we get a better understanding of whom we're talking to. One more second. Oh, looks like a good split. I can see it actually already here, so I'm the lucky one. I'm going to share the results in a second. Yeah, looks like we are done. Let's close it. And here we go. Can you see the results? Click on F&A, on the Abfrage, the survey button. Okay, so I give you results. So radiologists, good news. We have 7% radiologists here. Welcome to our group today. Data scientists, the biggest audience with 42%. Developers and engineers, 17 and 30%. And others just interested, would be interesting to hear who else is here, 26%. So 7% radiologists, 42 data scientists, 17 to 30% tech developers to engineers. So thanks and listening to you now, Erik.
Okay, so let me start with my presentation then. Let's see if I can maybe switch off. Okay, go to the first slide. So actually already some years ago, in 2016, there was an interesting publication from James Brink, who is the chairman of the radiology department in Stanford. And he said, the future of radiology lies in informatics and information technology. And this is, I just want to show this because this is a change that we are undergoing in our profession. Whereas in the past, we mainly were looking just simply at images and describing them. We now have a lot more information available. So this is already going on. And this is also one of the reasons why artificial intelligence has an increasing importance for our profession. So bits and bytes are becoming more important, and actually we will make clinical decisions based upon the information that we get, also the digital information. And it's expected that this will optimize health benefits, and it can also help us reducing costs. So what James said is over the next decade, we're likely to see augmented human intelligence, and our role as diagnosticians will change. And actually, this is why when talking about AI, I always think about these words. He says augmented intelligence, and this is actually what it means for us, and I will try to explain why. And he also said we need to be using informatics to ensure that we will continue to offer added value to our patients and the greater medical community. And this is actually very interesting because it's also what I think artificial intelligence will be able to do, add value to our patients and the greater medical community. A few years ago, we were shocked, the radiological community was shocked by what this man said, Geoffrey Hinton, and certainly the computer scientists will know him. He also got the Turing Award in 2018, which is like a Nobel Prize for computer scientists. But he said a few years ago, people should stop training radiologists now. So this created a real shock wave through the radiological community. And suddenly many radiologists started wondering, oh, what will happen? Will AI threaten us, or will it change our profession? But personally, I don't think so. I will explain you why. I first wanted to show you this. This is a 3D image of lungs, and you can see the airways in color. But you also see the lungs on both sides with white patches in it. And so actually this is a 3D reconstruction of a CT scan of lungs of a patient with COVID infection. And this is an example of how the infection can, let's say, affect the lungs. I will show you some other images where it becomes more obvious for you. Oh, I have to stop this. Yeah, so this is also an interesting slide. You can see 3 different patients from left to right. And the first patient is a very, very moderate type of infection. You see these patchy white areas in both lungs. And if you look at the one in the middle, you see that these are more clear than the first one, and the one on the right is even more. So actually you see 3 different stages of patients with COVID disease in the lungs, and these signs are quite typical. So what we see, and this is a very typical finding, this is called ground glass opacification. So we see these whitish areas in both lungs. It's important, you see them on both sides. And this is another sign that we often see. It's called crazy paving. It's more like a network, a reticular type of pattern that you see in the lungs. So actually, especially in China, where the disease came up first, they started to analyze the images, and they pretty quickly they found a few very typical abnormalities in the lungs of these patients. And if you want to know more about it, I would like to advise you to go to this website, Radiology Assistant, and there you will see all these findings. It's very well explained, but this is quite interesting. In an initial stage with every patient, you can see these ground glass opacification. Almost 90% has them. Almost 90% has them on both sides, and 80% has them posteriorly in the lungs. And there's many lungs involved, multilobular, which means many segments of the lungs. They also lie on the outside of the lungs, that's peripheral. And then these consolidations, what you saw in the third patient, these are more severe stages. Well, you see them not as frequent. And then you can, based upon these findings, you can also see that CT changes over time, and then you can divide these images in, or you can, let's say, analyze it and stage the patient. You can see if it's an early stage or more progressive or a peak stage. Or
Erik, can I interrupt you for a second?
Yes.
Because Rishu asked a question about the previous images.
Okay.
He was asking how is this opacification different than something like tuberculosis?
Yes. So it's the images that I showed, these ground glass opacifications, are not often seen in tuberculosis. That's a totally different kind of disease. This is what they call interstitial lung disease. It's fluid in the interstitial lung tissue. It's not in the lung spaces themselves. And tuberculosis is usually different, has different locations and kind of a different kind of aspect. In tuberculosis, you see more nodular type of abnormality. So different diseases are well known by radiologists and know the aspect. And we try to find for every disease very specific signs. And this is why I'm showing it. The ground glass opacification, it's not 100% specific for a COVID disease, but in many patients, as I showed, in more than 80% of these patients, you can see these. So that makes it quite difficult, typical, but that's radiology. You always have to combine several findings, which is the aspect of the lesion, the location of the lesion, and other things, so to come to a final diagnosis. And this is the profession of radiology. You have to combine, it's like making a puzzle, you know? So you have to find every abnormality and then make a total analysis of what you see. But of course, these are things, and that's what I wanted to show you, that you could also ask a computer to do. So this is actually what we are seeing, and this is a Dutch article from a Dutch journal. It became apparent that, so we make these images with CT scanners, and it became apparent that CT scanners from a Dutch company, Philips, are wanted in Italy, especially in China, because of the coronavirus. So this is a sign that the scanners were being used more intensively to make the diagnosis of these patients. And this also created some kind of a debate. This is an interesting article telling that there was a flare, that the debate flares over the usage of AI to detect COVID in lung scans and to use CT even. So that's still an ongoing discussion. And the reason is that it's a quite new disease. So people are still discussing about it. How should we diagnose it? What are the typical findings? And what should we do with it? So as you can see, the different radiological societies had discussions about it. And this is an opinion. Every society publishes an opinion. And this is the American College of Radiology. They published their opinion on March 22nd, which is quite recent. And so they said that CT should not be used to screen for or as a first-line test. So the discussion was about, do we use imaging, yes or no? If we use imaging, what do we use? Is it a chest X-ray or is it a CT scan? Or and if we use it, in what patients do we use it? Is it just to screen it or just to evaluate very sick patients, etc.? So this kind of discussion was going on, and then ACR said, well, CT should not be used to screen. So not for every patient coming in. So they said it should be used sparingly and reserved for hospitalized symptomatic patients with specific clinical indications for CT. And then a few days later, actually 2 days later, or 3 days, there was an opinion from the other Radiological Society of America, the RSNA, and they made this a consensus statement on reporting CT chest findings for COVID, and it was also endorsed by the American College, by the Society of Thoracic Radiology. So actually what they said is that at this time, CT screening for detection of COVID-19 is not recommended by most radiological societies. However, and that's some kind of a flexibility they showed here for the dynamics of the situation, they said, however, we anticipate that the use of CT in clinical management as well as incidental findings, potentially attributable to COVID-19, will evolve. So they say, okay, we can say this now, but you don't know, maybe next week we say something different because we have more experience. So this is how it is going, just to show you that everybody's looking for how to use this technology and the imaging in these patients. In the meantime,
is it right to say that we have a strong discussion if it's worth it or not to follow, but not following it would just leave us in a kind of situation that we might miss the opportunity to find something which could be helpful. Is that correct to summarize it like that?
Yes, absolutely. The main thing is that it was shown in, I forgot to tell you that CT scan shows abnormalities earlier than blood tests, than the PCR test. First of all, there's a shortage in PCR tests, so you cannot do them very easily because you don't have the material to do it. And secondly, it seems that on a CT scan, you can see abnormalities earlier than with that classical test. And furthermore, waiting for the results of a test takes more time. It takes hours and hours, sometimes even a day. With a CT scan, it's only a question of minutes. So this is what triggered the discussion. How should we use serologic tests? PCR, that's the name of the test. It's still the gold standard. Or should we make images? And if we use images, should it be simply a chest X-ray? Or should we do a low-dose CT scan, for example? So that's the reason why this was discussed. What's available, what can we do easily, and what's quick, and what's sensitive, right?
Thank you.
So, yeah, depending, because of this experience that was already gained during the first months of the crisis, even a scoring system was created so that we can give a score to patients from 1 to 6, which is, the lowest score is the chance of the patient having a COVID infection is very low, or score 5 is very high. This was published by the Dutch Radiological Society 27th of March. So that's also quite recent. So you see, insights are growing progressively. So we get a better idea of what we see and when do we see it. This is also from the Dutch Radiological Society. I'm not going to tell you this, explain you this in detail, but they offer hospitals 3 flow charts. And one flow chart is you do CT first, or the other one is you do the test first, the PCR, and the third one is the PCR first, but only in when you have a high prevalence or lack of PCR. What do you do then? So they give hospitals the opportunity to select one of these flow charts, and they leave it to their own. They can decide themselves how to do it. But this is the CT first flow chart, and you can see that they use this scoring system and not always the testing. So based upon the CT, they can say, okay, this is probable COVID, this is possible COVID, or this is no COVID. So in not all cases, they use the test anymore. This is, I'm not going to explain this in detail, but this is the Belgian test. I wanted to show you that everybody's still discussing about it. If you use imaging, if you don't use imaging, in what cases do you use imaging, etc., etc. So it's still a bit unclear, and there's ongoing discussion.
I have two questions. For Martin is one. Why is ACR not recommending CT for diagnosis?
Well, they always base their discussions upon the literature that has been published. So in medicine, they usually work in an evidence-based kind of model, which means that they use the scientific proof. But in the discussion in a disease like this, which is very recent and in which time frame it's quite difficult to have a lot of papers published about large patient groups, these scientific papers can still be discussed. So this is also the reason why everybody is still discussing about it, because there's no evidence, no sufficient scientific evidence. So one society in the earliest, if you're the earliest, you will maybe adhere to the first publications, and when you state something in after the others have published their opinion, then you can argue and publish based upon other papers that have appeared in the meantime. You can change and modify, and also based upon experience. And that's important, because a lot of discussions are influenced by how hospitals are being confronted with the disease. If there's too many patients and there's let's say a tsunami of patients, and they cannot deal with the situation by using the classical serological tests, well, some hospitals automatically say, no, in this situation, we have to use CT, but that's based upon experience. So it's always a combination, such a statement, based upon evidence and literature on one side, and on the other side, based upon experience. Is that clear?
Let's see if he responds, if it's fine for him. I see, just because we're just talking about that part, I think it makes sense to ask or continue with some of the questions I can see still coming up here. So now that you showed us that we have a discussion, and you showed that it might be faster in terms of maybe diagnosing COVID-19 using CT scans. One or two or three people actually already started to asking about the contamination problem. So if you have people getting a CT, what does it mean for using the chamber? You have to clean up everything. What's anything which is involved here? How is it? How expensive? Ranschaert actually asked. I wonder the same. So the question from Robert was, how much time does it take to sterilize CT rooms after COVID patient?
Yeah.
So in the same direction, Ranschaert, I wonder the same with both infected and uninfected patients going to the CT. How expensive is it to fully ensure that the CT itself does not become the vector to infect patients?
Yes, okay. I followed these discussions about the infections, and I know that there was in the beginning some discussion about it, but I can see that now there's so many hospitals using it that, when I asked them the same question, isn't there a danger of transmitting the disease by putting these patients on the scanner? Well, first of all, what they all do is they make a separate scanning room available for patients that they want to examine. First of all, they protect, of course, the radiographers or the technicians dealing with these patients. Secondly, the cleaning of the room. In the beginning, everybody said it takes a long time. Even in university hospitals, it took them about 45 minutes to clean the room. But progressively, the microbiologists got the insight that it's sufficient to clean the smooth surfaces. So this is now actually what they do in most situations. It just disinfect the surfaces of the scanner, which is the bed where the patient lies on, and even the gantry where the patient passes through. So this seems to be sufficient, and most hospitals are now doing it this way. So they just make a dedicated scanning room. Some go further. Some hospitals, they make a special scanning unit on the outside of the hospital, on the entrance. So it's a mobile scanning unit that they use for these patients. So actually, from a logistic point of view, it is possible to organize this. And I can simply tell you from experience and from communications with other radiologists doing this, that this is actually the preferred solution to do it, and very easy to do.
Thanks for the answer.
All right. So what is now the role of artificial intelligence for COVID-19 in general, not only for imaging? And there's 6 areas actually where they say AI can contribute. So first of all, of course, the early warnings and the alerts that the epidemic situation or a pandemic situation is occurring, the tracking and prediction of patients, that's also a very hot topic nowadays. The data dashboards, of course, everybody wants an overview of the evolution of the disease. And then diagnosis and prognosis is also a particular role where AI can play, has value. And then, of course, AI can also help in making, following treatments and cures and the social control as well. But let's talk about the diagnosis and prognosis. So this was one of the earlier paper, well, the latest papers actually in using AI from March 19th, was published in a major journal, Radiology. That's one of the most important journals in radiology. And this paper comes from China, as you can see. And they say AI distinguishes COVID-19 from community-acquired pneumonia on chest CT. So this is a normal pulmonary infection. COVID-19 is a viral infection. A community-acquired pneumonia is a totally different type of infection. So they showed with this paper that, well, their results, they say, they demonstrate that a machine learning approach using convolutional networks has the ability to distinguish COVID-19 infection from community-acquired pneumonia. So they say AI is able to make this diagnosis. This is another communication that was also in a discussion group on the RSNA website. And this is also based upon, well, a bit earlier, but here also a scientific paper was discussed. And what they say here, that in Wuhan, where they have about 24,000 cases with COVID and 23,000 suspected cases, they say that for the diagnosis also they refer to CT images, and that's a company that started developing a software for detecting the patients. And what they say is that the performance of the AI, they tested it in CT images of almost 1,000 patients from Wuhan, among which 475 were suspicious of COVID infection, and almost 500 were not. And they show that with this software, the sensitivity was 98% and the specificity was 87%. So it's very sensitive, but less specific. And the running time, they say, is 10 seconds per case. This is another paper showing that hospitals are deploying AI tools to detect. And it's not only to detect, as we see here, and as the previous publication also showed, but also to quantify. And this is something else. Quantify is calculate how much lung tissue is affected. And so this is also something that computer and AI algorithms can do perfectly, much better than the human eye, because with the human eye, you're just estimating, and you can maybe count for each lobe in the lung and then add it and then make an estimation. But this is rough estimation. With a computer, you can make a very precise analysis of how much lung tissue is affected. So this is also an interesting application for an AI tool. This is from a Chinese YouTube. I thought I wanted to show it because it's quite nice, but it's interesting. Without AI, they say a doctor spends about 15 minutes analyzing one case. That's 15 minutes. So, okay, it takes some time. But then with AI, CT scans can be interpreted in 20 seconds. That's also what the other publication said, 10 seconds. This one says 20 seconds. So that's a lot faster. So if you talk about management and efficiency, well, yeah, AI has the potential to do it a lot quicker and better and with a very high accuracy. That's what they say. And actually, AI could also assist. Well, this is an interesting graphic, I think. What they say here, you know, this curves already, everybody has seen them. And we have to flatten the curve, of course, but maybe the flattening can be hindered by the fact that even the capacity in the healthcare system is declining. For example, doctors are becoming ill themselves, or we don't have enough ventilation machines. So actually, there could be something stopping us from flattening the curve. And I think that AI could also assist in raising the capacity line by strengthening the workforce and providing care more efficiently. But of course, and this is interesting and also an ongoing discussion, there's already some AI tools available, but nevertheless, more and more people are saying, beware of the COVID tech cowboys. So it could also be a risk to start using them. So what are COVID tech cowboys? Well,
can I just ask a question in between again? From Bobby this time. So he asked, do models typically output a binary classification and the confidence, or rather a categorical severity rating?
Yes, there's different, of course, there's different tools available. The most simple one is just to say there's COVID or there's not, or usually it's not as simple as that. They give a probability score. You know, the findings of what we are seeing here matches it has a probability to match with COVID with that, a probability of, for example, 80 or 90%. So it gives you some additional material to make a decision or to make your diagnosis. And of course, there's also other tools available now from China that do both. They give a prognosis, an estimation of the probability, and they also give a quantification. So it depends on what kind of algorithm is used. But now about these COVID tech cowboys. So what are cowboys? Well, actually what we see, and that's true, that many researchers, but also companies around the world are attempting to develop AI tools. So it's not really new, it's not really unique. And some are claiming levels of accuracy that are above or beyond what anyone had previously claimed on any other commonly known image findings, such as a pneumonia. So we are pretty surprised by the results. Or some claim they obtain these results. And there has been a significant increase in non-regulated or incorrectly certified class 1 COVID AI devices. So those provide little or no transparency on their training, what kind of data are being used, and the validation. How is this software tested? And of course, the data are scarce, that's a fact. So these cowboys, let's say, they don't have evidence to demonstrate effectiveness in a real clinical workflow with real world data. They could be effective in laboratory circumstances, which does not mean that they are effective in another location, in a specific hospital, in a totally different country. This is a paper that was actually published today in a Dutch paper, one of the leading papers in the Netherlands, the NRC. And they say technological aid from China is not for free. A Chinese algorithm can help us with quick diagnosis of corona patients, but you pay for it with patient data. Don't do it, this journalist says. And I'm going to translate for you what's on the middle. So the first part says, a global health crisis is not the time to be seduced by commercial tech companies from China. There's too much uncertainty for the patient's privacy. And actually, what they say in the paper is that we should use the momentum to start developing algorithms together with, in this paper, Dutch hospitals, could be also French or German, of course, and talk to each other. We should talk to each other about the ethical codes in the interest of the patient. And actually, we should share our experience with European member states so that a European-wide policy for AI in care can be implemented with sufficient protection of patients' rights. And I think this is pretty correct. So what should hospitals not do? Well, they should not choose an unproven system, because then they potentially open themselves up to wildly inaccurate technology that could actually hinder frontline care directly. And what should they do? Well, I think that hospitals should look for tried and tested, appropriately regulated, well-published AI software which is specifically designed for the screening and the detection of lung disease in risk populations, and also with useful features suitable for a pandemic that include patient registration, tracking, and integration with pathology results. So hospitals wanting to help with data sharing to enable further research, they should partner with official collaborations, such as our project, which is the the COVID initiative, and which is also supported, by the way, by the Radiological Society of North America. So yes, we set up a research project, and Ángel and Jonathan will tell you more about it. And here you can see the address of the website. So this is actually based upon a scientific research, and which is initiated by the Netherlands Cancer Institute, and my partner in research is Laurens Topff. And then we also have support from my society, and then we have the partners that you know in the meantime, which is Quibim, Robovision, and for the legal matters, we partner with A Contrario. And of course, this is the EuSoMII website where you can also follow what we are doing and also follow our webinars. So thank you for allowing me to give this presentation.
Thank you very much, Erik. Of course, it would be cool if you make the presentation available afterwards. That would be awesome. I still have 3 questions before we continue with Jonathan. So there's one question: is parenchyma analysis tool used for diagnosing COVID-19?
Oops, sorry, I didn't understand.
Is parenchyma analysis tool used for diagnosing COVID-19?
Parenchyma analysis tool, well, I'm not sure if I completely understand it, but we are not making any functional evaluation of the airflow. We just make a morphological analysis, and also we measure the amount of tissue that is affected, but we don't measure anything regarding the obstruction of airways, etc.
Thank you. From risk, do you think imaging biomarkers not detectable by human eyes in the first CT, maybe with mild signs on CT at first, could predict which patients are going to develop a critical condition in the following days?
Mm-hmm. Yeah, that's a very interesting question, and I hope we will be able to analyze that and find biomarkers that can help us in predicting how the patients will evolve. Yes, that's certainly, that should be among the goals of making this software and doing this analysis.
And I have one question from Pierre. I think it's really refers to what you said about should we share data with China or not. And I think it's probably a hard question anyway to look at how we can work more closely together, not giving up everything. Big question. Pierre asks, why would AI from European countries inherently be better than AI from Chinese countries?
I'm not saying that it will inherently be better, but the thing is that we have to know what, first of all, with Chinese products, there might be a bias in the population. First, it's a totally different population. You don't know, but the AI algorithm might make, can have a bias in its mechanism to make a, let's say, to make an analysis. Furthermore, you have to be sure about how the data were selected, what kind of data were used. Maybe the type of scanners was totally different, or the way the patients were scanned was totally different. You don't know for sure how the images were annotated. This is also of high importance, as you know, with algorithms. If you rubbish in is rubbish out. So if you're not sure about how the data were annotated, then you can have doubts about it. Actually, the essence is that you can only be sure about algorithms that are being tested in a scientific way. What is the outcome if we try Chinese software in a European country with European scans, with European images? And this is something you should ask yourself, and it just simply has to be shown. And it's also, that's some scientific evidence that you need before you start using these tools to make clinical decisions, because this affects the treatment and the health of patients. So it's quite important to know how the software was created and how effective it is.
I think we have some cool questions here. It's I don't want to disturb Jonathan and Ángel, but let's say 2 questions, and I would ask Erik, if you, when Jonathan is speaking, have a look at the Q&A question section to see if you can answer it and type it in a second. So from a business case point of view, Reinhard is asking, how does the cost of a CT diagnosis compare to PCR?
Actually, I don't have an idea about that, to be honest. PCR is a quite, no, I'm not going to say it. I don't know. I'm sorry for that.
It's work in progress, so it's you need to figure it out what
Yes.
the cost really means. It's an initiative actually. So let's say we leave the other questions. It's still open in the Q&A section. Don't worry about it. It's recognized and we can answer that. Erik, have a look at it, please. And I would actually love to welcome Jonathan as well, who has been waiting for his part. But before we start, also just you said a few words about yourself. So you're a founder of Robovision.ai. Yes.
Yes.
What are you doing on a daily basis?
My personal job, I'm the CEO of the company, so I'm not programming Python anymore, unfortunately. My daily activity is mainly shaping alliances over ecosystems and understanding interfaces with new business opportunities. Today, we were profounding our relationship with Microsoft, preparing a statement of the leadership of Microsoft about this project. So I am very much an alliance manager right now, choosing which business direction my company goes and strategic decisions. I mean, like the call with Erik, I mean, 2 weeks ago, we're a company with a generic AI solution, and all of a sudden I need to decide to put 15 people on a project for the greater good of the world. So it's challenging sometimes, because as a scale up, I have 65 people that I have to pay the salaries for. It's not obvious just to choose in 5 minutes, let's go for a COVID-19 AI solution. Finances are not there, and it's pro bono.
Yeah, well, you're focusing on deep learning.
Yes, that's correct.
Okay. So how many people did you say you have in your company? 56?
65 people.
65.
Yeah.
Okay. Interesting. So you have started to work on the project. Your talk will be how to fight the COVID-19 virus with AI for medical imaging, right?
Well, yeah, but I will.
No, deep learning. Sorry, that was Erik.
So I will talk about deep learning most of the time, and I will apply it to business cases. I understood that only 7% of the audience was a radiologist, so a lot of people have a more broader profession. I think it's interesting to take a look where we came from with Robovision and why we are in medical right now.
Yeah, it would be interesting. I'm happy to listen to your talk.
Okay, let's start. Share. Slideshow. So as I said, we are with a company of 65 people. Our product is, wait, I'm going to, you see my...
Yes, that's perfect. Yeah. We can see it.
So we have a platform, a no-code platform to really apply data creation at scale with a lot of potential labelers. So we have labelers, a crowd of 65,000 people as well over all the world. And we are basically automating the complete funnel from data to deep learning. Our history is actually a platform in 3 sectors: agriculture, manufacturing, and smart cities. And from these different applications, we've learned that the solution is so powerful that we can also apply it to medical. Our go-to-market is mainly via the big tech companies like NVIDIA, IBM, Google, Microsoft, NetApp, and Pure Storage. So we, via these channels, we are finding our business. So I see to the left, it's agricultural, so robots that can plant cuttings automatically, manufacturing, quality control, and smart city. This was the past, but of course, for 1.5 years, we're into medical, and I will talk about it later. We're very much allied with university, Ghent University. I also give practica for the last year engineering students in AI, so deep learning course, as a guest lecturer. And yeah, we have strong alliances with all the different research groups. And this is extremely important for us to get the best people from the hiring market. And where do we come from? Actually, we started with machine vision projects. I was a machine vision engineer myself, educated in 1999 in Zurich in the ETH, Professor Luc van Gool, my first machine vision project. And everything machine vision at the time and for the years shortly afterwards was actually based on manual programming, so to say, software 1.0. As a software engineer, being a physicist in education or a mathematician, you needed to abstract the scenery first, for instance, in the right bottom corner, to create your region of interest, to decide how to detect a certain aspect, and then to create all the algorithm. It was really interesting because you need expert people to create sophisticated algorithms. And these algorithms in the software 1.0 era are if-then-else algorithms. They're like large pieces of code made by one or more software engineers that abstract the scenery in a diagram-like way. And the problem with this way of thinking is that it's mostly very linear because you just follow an abstraction path. You need to make important decisions up front, like the background-foreground segmentation. You need to set thresholds. And the flexibility of this approach is limited because at some point, if you're commissioning a machine vision project in a company, yeah, they will want to add a new product type, and then you have to go there and edit the thresholds and the areas of the abstraction. So in 2010, after I had been a consultant for about 8 years, I went back to the university to my old friend Benjamin Schrouwen, Professor Benjamin Schrouwen, and I told him, like, I'm just stuck with this manual programming. I want more tooling. I want to automate intelligence. And at the time in 2010, AI was not really a hype. It was machine learning, machine vision. The naming was also not really as a buzzword right now. But at the same time, I learned a lot. I hired my CTO, Tim Wageman, and we implemented AI systems from that period. So in 2012, we started with machine learning, so manual feature extraction, combined with neural networks for classification. But this was still like not so automated AI. And then soon afterwards, we decided to go all out for deep learning. At the time, it was a framework called Theano, which did the abstraction and the conversion into CUDA drivers. And yeah, for us, it was really a dream because in deep learning, you're able to, for instance, a ResNet-50 neural network, you're able to input arbitrary data types and give some examples in the form of just annotated information and really regress the whole deep neural net into a classification engine. So the feature extraction is embedded in the deep neural networks. And that's the first lesson I want to give to the people not so familiar with AI. With deep learning, we've actually come to a new paradigm called software 2.0. And we've really said bye-bye to the old paradigm of manual if-then-else like programming. And if you look at our data engineers and PhDs working on deep learning, if we're talking about detection and so on, they're almost never using if-then-else code anymore. They're using structures in deep learning. They're using different deep nets, and they're just combining techniques in deep neural network technology. So in a way, to conclude with this AI, history of AI, AI has been there since 1956. It has been, the term has been there for a long time, Professor McCarthy at Dartmouth College posed already the bout ambition in '56, saying like, what if machines could program themselves? What if machines can write software? But for a long time, it has been a dream, an impossible dream, with winters and summers of AI. And only in the 80s, 90s, when programming was much more easy because of high-level object-oriented languages and the merger between mathematicians, statisticians, and information technologists, this machine learning gained a lot of power in the scenery. I was part of the scenery in 1999. I was part of the Institute of Neuroinformatics, a Zurich-based institute where biologists, physicists, mathematicians were working together really to reverse engineer the brain. And it was a fantastic time. I remember that they were just reading neurons from cats and trying to understand what they actually were seeing. So in a way, they could predict what a cat was dreaming about because they knew the output of the neurons in the back of their brain, in the cortex V21, what they would output if they saw a mouse. And actually, when they dreamt about a mouse, they could with some certainty say, like, probably they've been dreaming about a mouse. So this deep learning paradigm is really disrupting the old era of the von Neumann machine. The von Neumann machine, which is the typical processor combined with memory architecture, that drove many engineers in the last decades into a linear thinking model, meaning that by writing code, you have to think single-threaded. And these multi-threaded processors are there, of course, for quite some time. But most of the people here in the audience, I presume, were still educated in this old paradigm of you have to write code as a linear thing. And with deep learning, what we see is the power of non-linearities combined with parallelism, with huge parallelism. In fact, typical brain reactions are, of course, magnitudes slower than a computer, even slower than the typical arithmetic operations in your mobile phone. I mean, typical times of an accident potential is several milliseconds as a response time or the time constants involved. But because of the huge parallelism, a human brain is still far superior in understanding reality than a deep learning engine. And we could say that deep learning has automated very specific algorithm creation. For instance, in the case of this human face, the typical intermediate steps are not really engineered by humans. They're engineered by an algorithm called gradient descent. And this algorithm is just tweaking the connections between these layers in such a way that the output matches the input in the best possible way. And if you give it a lot of these examples, like cats and dogs, the typical paradigm of deep learning, then it will just transform and edit these, reinforce or weaken these typical links between these neurons. And so to say, that's also a problem because the intelligence is embedded in connections. And of course, connections themselves are not explaining reality. So a lot of situations in the deep learning community, for instance, related to society, like detecting criminality, or even in radiology, detecting some facts, doing some analysis on a radiological image, is actually, well, not explainable for now. So they're terribly good at a very pinpointed problem, but they're not so good at explaining why they took that decision. And to a certain extent, it's really the media, which is reporting a lot about AI, is making one big bunch about it, which is kind of a problem, because if you tell your aunt at a Christmas party, like, is this AI? She will say, like, yeah, it's AI. It seems very high tech and with a lot of robots. But of course, we all know that this is old school programming. This is software 1.0. Although it looks very high tech, it is very stupid. It is very A to B programming with certain conditions and sensors. But if you look at the typical paradigm, the typical challenge of society to make a more safer traffic situation in the world, this can never be done by heuristic programming. Never with heuristic rules, with if-then-else rules, we can make a safe car that autonomously drives a city traffic. So also this, where the champion Lee Sedol is actually being challenged by AlphaGo, it is also something which is quite special, because if you look at all the different options that a typical Go game has, it is more options like atoms in the complete universe. So, I mean, these techniques have evolved, and they go much further than the typical Deep Blue-like chess challenges of the 90s. So, a lot of these things can be applied to arbitrary camera data, and deep learning has found its first successes in the visual domain, because it was so easy to annotate and people understood how to do this. With Robovision, how do we approach the market? We want to automate expertise. We want to democratize AI, meaning that the typical situation in the market right now is that a specific company is actually hiring a consultant, an expert, to teach an algorithm. And this expert, very often with Python, is actually training an algorithm and has a certain detection. Now, at a certain point, this company decides to go all out for AI and needs a lot of models because it has a lot of problems and challenges within their ecosystem. Then, of course, hiring a lot of experts becomes terribly expensive, and not to say that it's really difficult to absorb the knowledge afterwards. And here with Robovision, our business value proposition is really to concentrate on the tooling of AI and to make sure that non-data scientists, non-programmers can actually make a deep learning model. And this is the admin view of our stack. It contains pipelines, deployments, a storage, and AI store as well. We try to make an SAP system, so a no-code system for an AI ecosystem. You can still edit all kinds of things like API endpoints, and even you can set all the specifications of your typical deep learning models, but it's intended to be used in broad context. Context like cell analysis, like for instance, red blood cell analysis, but also to plant plants, because our biggest model of, how could I say, return on investment, our profit model is a license-based model throughout the world in agriculture. So all of these agricultural companies, they're paying a certain fee per year to teach new models. And they do that in the following way. They just create a new model by annotating different plants. And they do that, it just takes a couple of minutes to annotate. And after this annotation, they go to the user interface again, and they train actually the model. And 10 minutes later, a non-educated person, wherever in the world, we're based in Japan, Australia, Canada, Brazil, we're everywhere, can just train a deep learning model for a robot. So the robot understands a new plant type and can automatically route this plant type. So if we then take a look at how this model is there, we give access to a lot of labelers in every country of the world. We have labelers in Venezuela, Nigeria, in many countries, and they get a request just like an Uber driver gets a request, and they will start labeling for some farmer somewhere in Canada. So that's the business model that we have. We are the broker of intelligence, and this intelligence is being created not by humans but by a deep learning platform. At this moment, we are focusing a lot on 3D. For instance, what you see here is a tulip annotation system, and it is intended to actually make deep learning models in the tulip. So here you have a robot which understands tulips and can plant them automatically. And all of these things, they are actually done with the same kind of stack, with the same kind of technology. So a lot of our go-to-market is also materializing in real robots and real machines in OEM contracts with those different partners and customers, and is actually disrupting value chains. It's really important to understand that, for instance, a rose cutter, a machine that understands the complete topology of a rose, is being built in a couple of months. So it's really very, very much the same paradigm in different ecosystems. For instance, in this ecosystem, it's labeling in 3D, and you have to label so the robot understands how to see, how to look at a plant and how to cut it automatically. So in this case, the rose cutter. So in all these ecosystems, we are helping companies to, with their AI, go to market in OEM-like way. For instance, here with CNH. So a lot of these things. Also in retail, we are now very active with Colruyt, a Belgian chain, where they have deep learning automations at the top of the cashier. So to actually detect all kinds of organic products. And it's quite easy to train. Why do they use it? Because they're independent. They do not need experts. They just need to pay the fee for the license, and then they just handle it themselves. They can create deep learning models themselves. And here you see the example. You just put your fruits and vegetables there, and the camera, without an algorithm being created by a human, can just say like, okay, there. Another thing is, for instance, making pictures of fruits and vegetables to connect them with deep learning with certain genes that are responsible for texture, features and artifacts. So very important for the breeders of this world. Another application is actually the application for the NIH. So what we did is with the NIH, we set up a large crowdsourcing experiment where a lot of laborers were actually annotating organs, and we were creating a deep learning model with this. And together with the NIH, American government, we took a lot of data from all these hospitals, we routed it to many labelers, and in the end, we had built such a model. And our vision for the future is that what happens in a ecosystem like mobile phone technology with the App Store and with the Play Store of Google is going to happen for B2B and for other types of expertise. So we will live in a world with a lot of experts where you just can download or access an API and it will do some specific applications for you. And this dedicated to medical is actually here. I will show you the workflow. So we're going to set up a labeling experiment for the labeling of radiological images. So we will just onboard some radiologists. We will go to the labeling and just give some classes. We will go to the labeling session itself, and we will start labeling. Here in this case, it will actually label lesions, brain lesions.
Jonathan, can I just ask you a question in between? Since it's as you say, COVID-19. Given the current initiative, also a question to Erik and you both. So looking at the number of CT scans you've used, and you're talking about labeling at the moment, how much scans did you have for the current initiative at the moment?
We now have, I think we've onboarded like 1,500. I don't know if it's 1,500 or 2,000. We had a call with Laurens, but it's just beginning. We will have thousands and thousands of patients, and the labeling itself, I will show you here, will happen actually with extremely easy web interfaces. So all these radiologists from Madrid to Copenhagen, they will just get a web link. They can open it even on their iPad because it's fully cloud supported. So it's not using any resources from on the on-prem device. And you just go and you start with a smart brush. You start just labeling these COVID-19 things in 3D. So you can just actually, you see it appearing in the right bottom corner. You see these COVID things appearing in 3D. So you could say that it's almost like an AutoCAD environment for radiologists.
Let me help to clarify that for a second. So what's the kind of workflow you're talking about here? So say I'm a hospital and I would be interested to join the initiative. What does it mean? Do you say to give me a link, and am I uploading my own CT data, or is it the data you have?
Well, it's a perfect time to show you this animation. So you're a hospital, you're Bergamo. You upload it to a data center in Amsterdam. This data center in Amsterdam is dispatching all these kind of lung scans to radiologists. So as you see here, wait 1 second. And these radiologists, they get a task, just like an Uber driver gets a task, and they say like, can you just annotate the COVID things? And all these annotations, they come back to a deep learning server in Germany, and there it will be trained into a model. And a hospital in Madrid, for instance, can just upload a DICOM to the super server and get a result where this result has the patient coronavirus, how heavy are the lungs damaged, and is intensive care needed for the patient? Does that answer your question?
Part of it, but we're working on getting deeper into that. So,
Yeah.
so one question here from the audience as well, and I think it goes in the same direction. So we need to have a closer look at what's happening here. How do you ensure GDPR compliance in this workflow? Uploading patients' data. You showed actually the flow of information from Madrid to somewhere people and radiologists sitting somewhere in the country.
Well, one very important answer to that is work with GDPR specialists from day one, even from day zero. So we decided to work with A Contrario, well-known GDPR specialist office in Belgium, and they made all the contracts and the workflows, and they're really guiding us into all these different interactions and how to interface systems. And also our supporters, Microsoft, Google, and NVIDIA, have their dedicated GDPR team. So they are sponsoring this also on the condition that, of course, it's legally sound. And for instance, the MUC application of Ángel of Quibim is ensuring this anonymization and making sure that no patient data is leaked. But maybe Ángel himself can say you in his talk a bit more about it, because that's his part.
Okay, so just one question again regarding this workflow. So the radiologists working inside of the initiative, so is it part of a team, or is it something, you know, I would be a radiologist, say I would like to participate. What's how much time does it need from my side? How does that work?
Well, I would say depending on the complexity of the pathology, because we also have to work with non-COVID cases, and then of course it's just approving that the lung is non-COVID infected. And a difficult case can, I think, maybe take minutes to annotate, but other cases are with the smart brush tooling, maybe 20 to 30 seconds. So I would say that it's the power of the crowd. If we just send it to enough radiologists, we will have a lot of data soon, and we will be able to train one of the best models out there on Earth to fight the COVID-19 crisis with CT analysis.
So one call to the radiologists in the audience today would be, hey, join us, right?
Yeah, indeed. Yes.
I have a question here from Martin. I think that goes directly into how you, the interface you showed here. He asks, will the COVID AI tool be a 2D based algorithm, or will it take the features 3D characteristics?
It will be natively 3D. So it will be, I mean, if the radiologists in the audience have visited some medical deep learning conference, it will be similar to the UNet, but then a UNet version to 3D environment. So it will natively use the 3D structure of the data.
And Steve, I want to know how it regarding the workflow. Do you send the same case to multiple radiologists to build a consensus label?
Yes, that's a very good thing. And I will show you, because from the software itself, it is embedded in the platform. So we can actually, I will check where it is exactly. It's not here, but you can actually set, it's not in this video overview, but when you do the user setup, you can state how many users have to be checked the same model. There is also a user check, so there is some kind of test that a certain new radiologist is applied to, so to see if he has enough consensus with the larger group of radiologists and to detect anomalies in the labeling. So one of the key features of this platform is also anomaly detection in the labeling process itself, because we all know with deep learning that garbage in is garbage out.
Yeah, if I can add something, Jonathan, this is also in what we are collaborating about with the American societies, is to develop a standardized way of labeling the images so that everybody is using the same kind of labeling codes and technology or system to annotate the images. So we want some kind of standardization.
Yes, exactly.
Interesting. So
that's the power of the cloud also, because I mean, you have to imagine that we're talking to people very close to Satya Nadella. Microsoft has really said like, okay, we will really support this as a lighthouse. And the cloud, it's one of the first brilliant use cases of AI in the cloud, because you have such a massive deployment force. You just send somebody a link basically with a YouTube onboarding video, and he's creating value for the AI model.
okay. I saw Eugene. I actually allowed you to speak up. You need to turn your audio on for a second. Otherwise, you can also always use the Q&A section below in the navigation bar for questions. So what did you want to add here or ask?
Hello?
Yes, we can hear you.
Okay, it's fine. So just my question is, what is your estimation? How many radiologists do you need to assess all images you have? Just approximately.
We are now working with a number of 100 radiologists. So if they can each do like 20, 30 patients, we have a brilliant, nice deep learning data set to train a nice deep learning network on that.
Yeah, this is also unique about this project. It's the fact that every participating hospital is able to allow their radiologists to annotate images. So if they are interested in participating, they can do so, and they will gain some experience with developing AI tools themselves. So this is a quite unique opportunity to, let's say, to allow hospitals to and radiologists to get more experience with developing AI tools.
Interesting. And a question, and I think it's in a similar direction, like how this initiative will be growing over time. From Andre is asking, are you intending to collaborate with the EU Commission in order to expand this project to the level of the EU and maybe beyond that?
Yes, we had an official letter from the Ministry of Information, Philippe de Backer, to the European Commission, Mr. Breton, asking for just to recommend this project as a lighthouse. So we're actively working on our relationship with the EU Commission to be able to scale this in the most professional way possible.
Thanks for the answer.
Okay. I'm about to end this thing, so if there are any more questions, I will see if I have some more relevant slides. 1 second.
I think this was one of the interesting parts from you, just to see how the workflow is and what you're working on regarding deep learning and how that could be used in that context. So
one very important thing about deep learning, I mean, with the same kind of ResNet 50, which is an extremely powerful, very multi-purpose deep neural net, we're able to detect the pose of these workers, for instance, and see if they have security goggles on. Now, all of you understand that there is a lot of talk about masks nowadays, and if you walk around in Singapore without a mask, you'll even be fined or will be fined soon, because they're distributing it to the whole population. So deep neural networks will not only fight the crisis on a medical level, but also on a behavioral detection model. So I just wanted to highlight that as well.
Sure, that might be even a privacy issue again. So how far do we want to go? But thanks for that kind of just bringing that up here, Jonathan. Thank you. So I hope we have more time also with Ángel.
Yes,
and turning over to him.
Yes, I will need to. I will still be in the call, but I have a call with Redmond, Microsoft, the next couple of minutes. So I will be on mute, but I will join the discussion later on. Okay.
Yeah. So maybe one last question, because for Mark here, it refers to what you've been saying. Do you only distribute the model, or is it also the data shared between the participating hospitals?
It's a research tracker, so it means that it will be published, so it will be clear how the research has been done, but the data will not be shared with everyone. We have much more data than only the DICOM files, so we have to make sure that people that are in connection to us are interfacing with us along the GDPR guidelines and all legal frameworks that we put up.
Yes, it will be possible to share data in the context of further research.
Yeah, thank you. So again, for you guys in the panel, have a look at the F&A for Q&A questions from the people. If something is open, just make sure that we have everything answered.
Okay, thank you very much.
Yeah, thanks, Jonathan, so far. Ángel, so happy to have you on the call as well. So you're a founder as well, as I know. So what is your company all about here?
Yes, I'm the founder of biomarkers in medicine, and actually what basically we want is to change the paradigm in radiology and to extract as many information as possible from the images, quantitative information. We don't like to say that we are an AI focused company. We think that AI has to be a tool, not the goal of the company. So actually what we have done is to use AI to accelerate all our pipelines, actually. So you have to see our algorithms as a way of extracting this quantitative information. And then AI helps us to accelerate all the analysis, and to make it more automated. So my background is engineering. I'm electronics engineering. Then I did a PhD in image processing, and I've been working with radiologists for years inside the reading rooms of radiologists. And then, we noticed that we needed kind of significant change in radiology, and we wanted to develop a platform that in the end became the core business of Quibim. So let me put the slides if possible. Can you see my screen?
Ángel, we can see your screen, but we recognize, I think Erik has a good comment here, that the audio is getting a little bit worse. Can you just try to switch off video, so we have only screen sharing for a second, and we just listen to you sharing the screen?
Okay.
Let's try if that makes it better. Thank you.
Oh, thanks to you. So the idea is that we understand that if we want to have an impact in radiology and medicine using AI algorithms, we will not achieve anything if we just develop AI models, right? And we have quite wide experience in develop those algorithms and solutions, but it arrived a moment when we thought, okay, if we want to get into the workflow, then we need to change the way radiologists access the information today. So that's how we called it seamless AI integration in clinical routine, basically. So historically, we have been working in 4 main areas, one related to brain and everything of neurodegenerative diseases, and also lesions detection in white matter, for example. Then in chest, which is the one obviously more related to COVID, we have a wide experience on COPD analysis, fibrosis, and also chest X-rays classifications. We are one of the few companies with CE mark chest X-ray classification using AI. Then in MSK, and this comes from a PhD, and where we started working on bone analysis together with cartilage assessment. So as of now, we have a comprehensive joints analysis in the company. And finally, everything related to tumors and mainly body analysis, prostate cancer, rectal cancer, breast, and so on. No? So we decided to put together all this science in basically the product that Quibim developed technologically. It's what we call Quibim Precision Platform, and it can be seen as a kind of engine for post-processing and for analysis. And this platform allows to centralize images, to add plugins based on AI, and finally incorporates a very intuitive way of reporting the results at a patient level. And apart from that, we wanted to build as well let's say the population level of the platform. No? This is an example of how the apps look like inside. You can see here chest X-rays classification, MSK, all the oncology part. So it's kind of apps-oriented environment. So as of today, as you know, we are a lot of companies developing solutions. And one of the thoughts we had is, okay, we are going to develop a platform. Do we want this platform to be used by the radiologist at all? Do we want them clicking the options, buttons? Do they need to learn a new way of using a user interface? And for that, obviously, you need to discuss on the input, right, to your tool. And one of my obsessions is, I don't want radiologists to be using us at all. We should be as transparent as possible. Even they should not notice that we are in the hospital, because sometimes in the end, you cannot interrupt the workflow. So what is happening right now is that there are so many companies in the AI space that if all of us are developing standalone solutions, so we will end up with something like this for the radiologists, is everyone is trying to deploy workstations or client server solutions with many different user interfaces. Obviously, this is a joke. We are not going to use Kinect. But what we want basically is to be as seamless as possible, no? And seamless means with no gaps, for sure. And this is what we understand with seamless, no? This is the conventional workflow of radiology in blue, where we have the patient going to the clinician asking for an examination. Then we extract this qualitative information from the images, and the radiologist reviews them. And then we have this radiology report going back to the clinician. No? So what happens if we take this data and we extract all the images plus the metadata associated, we do the image preparation, all the post-processing, we apply the AI tools and biomarkers, and we send back these quantitative reports. No? Then what we achieve is an integrated diagnosis. We enrich the radiology report with quantitative information. And finally, without noticing it, when the radiologist opens the case, the report resulting from the quantitative analysis is already there. So even for the COVID project, we want to build seamless infrastructure, because if the uploading of cases to the platform is time consuming, we will not have a lot of cases from the participating centers. No? So how we work in clinical routine in the hospitals we are working with basically is that as soon as cases arrive to the PACS, we have an automated rules engine. This automated rules engine basically detects new studies. We are continuously checking for new studies, new cases, matching the protocol that we have configured in our AI analysis tools. And then once we detect it, we send back the results to the PACS in the execution time. No? Typically for AI stuff like chest X-rays classification, CT classification, we can have it in seconds, the inference. And once it's back, when the radiologist will open the case, they will already have the information, no? Not only the images, but also the results of the analysis. No? And the results in the end, we think that they have to be easily understandable, not only by the radiologist. I think the radiologist is very important, but for us, we want radiology to change, and that's the reason why our reports are even understandable by the patient. We think that all of us know when we have a blood test report, even patients know when something's not going properly because they see themselves out of a range for a specific parameter, for example, it can be cholesterol. You see very quickly when you are out of range. And we wanted this kind of very intuitive reports for the clinicians. The clinicians are asking them they are always telling us, oh, thanks God, in the end, I have kind of blood test-like report in radiology, not heterogeneous text anymore. And actually, it's not substituting the report of the radiologist, but adding objective information, right? So how we do that in the case, for example, of COVID, where we have a kind of a centralized repository in the cloud, and we are working, we have strong relationship both with Microsoft Azure and also with NVIDIA. We are part of the NVIDIA Inception program. And this is the scheme, right? So Quibim Precision has a cloud site. You can see here the cloud environment. And this is the hospital side. So what we do is we deploy a small solution called the MUC. It's a medical imaging universal connector. Basically, this MUC is interfacing with the devices and the hospital information systems, and it's pushing data to the cloud. This data is dissociated data. So that means the images here are not, cannot be associated to any identity. And here in the hospital, the only way of accessing the information of the patients is if you keep a traceability on the code that the MUC assigned to the cloud side and the real identity of the patient. No? So here in the cloud side, if you access, for example, from any other environment that is not the hospital, like your house, what you will see is a list of codes. No? So the data will be anonymized, and unless you keep that traceability, you will not be able to assign that information again. No? So basically for a hospital, what we are doing right now is that we are installing MUCs in all the hospitals involved in the Imaging COVID-19 AI project. And this is the very fast way to get ensuring anonymization and the upload of the information to the cloud. In the platform, we have a viewer, but in the project, this role will be assumed by the Robovision because they have a very good annotation environment, and it was quite clear, and it accepts also multi-user information. Here in the Quibim annotation environment, we have the chance of loading the results of AI. This is an example of, in our web-based viewer, how we can load the results of the AI detection, and we can edit them. This was a requirement from FDA, for example. Even if you have an algorithm generating masks based on AI, the radiologist has to be able to edit them. No? This is one of the basics, and we are doing that as well for all the AI segmentation stuff that we have. Also, I mean, it allows us to quantify, and we have many different biomarkers. No? In the end, what we want to provide is the radiology report of the future, that we call it to be actionable, quantitative, and automated. And then we decided, you know, in March 14, we decided to set up a research-only environment in web. This was the imaging COVID-19.quibim.com platform. And basically, we clearly announced that the results of the analysis could not be used for diagnostic purposes because it was research only. And we have had a lot of users registering into the platform. We have now around 400 users. And we have received many CT and X-rays cases. And this platform, let's say that right now will keep us a platform exclusively for non-EU sites, but everything related to European Union will be scaled up to the project that we are presenting here today. So we will have a different environment inside the platform. We will have a space for the EU and non-EU participants, because we already have many cases here in this platform from Korea, from US, from for example, from Mexico, Argentina, and obviously we want to keep collaborating and working with those sites as a kind of open data approach. Inside the platform, we have two main models as of now, and these models obviously are not the ones that will be developed in the end of the Imaging COVID-19 AI project. This actually, this one for chest X-rays, this is C cleared. This is not COVID-19 specific. This is our chest X-rays classification that obviously is sensitive to pneumonia cases as well. These are a pair of cases, one with a portable device. And basically what we have to think on is that especially our approach to AI development is not to focus on providing a diagnosis. We are giving more and more importance to the abnormal probability that goes from 0 to 1. And the threshold for a study to be labeled as abnormal is 0.3. We have a paper published in Clinical Radiology where we did many comparisons on our sensitivity and specificity on normal versus abnormal, and 0.3 is our best threshold for splitting those populations. No? And as you can see, these are as well COVID-19 cases where we can detect all the different regions and give special importance to have this kind of indicator in clinical routine. And we have already started the use of this solution in some hospitals of Madrid, because radiologists are reporting around 500 chest X-rays a day, and they claim that they are not as, I would say, mind healthy when they are in X-ray number 1, that they are in X-ray number 499. No? So they need kind of stable number that's not tired, that's not subjective, that's objective, and this number will be always, you know, providing information to support the radiologist the case. No? This is another example of a COVID-19 case, and obviously the findings provided. It's important to know that actually the heat maps are focusing to the class, for example, in these findings, to the class that is giving the highest weight to the abnormal probability classifier. Here we are using a kind of referee fully connected network after a bench of classifiers working on a specific disease. And what we see here is the attention map of the classifier giving the highest weight to the abnormal probability score. What we did afterwards, and we launched in March 14, was this very preliminary classifier. And we are happy that in this project, in the Imaging 19 AI COVID, Imaging COVID-19 AI project, together with Robovision, we will do an internal hackathon on the data sets uploaded to the open repository. And in this hackathon, basically, we expect to achieve the best performing algorithm.
Ángel, one question, because from Robert. Robert, can you talk? You wanted to know more about the probability threshold, right?
Yeah,
right. Hello, Ángel. It's Robert from Poland. I was just going to ask you about the probability threshold. You said you are using 0.3, which I understand is 30%, right? Probability threshold, right?
It's 0.3, yes.
So anything above 0.3 you consider to be a positive finding?
It's abnormal, yes. Not a COVID case, not COVID. But in the case of normal versus abnormal chest X-rays, going to any kind of finding, like cardiac findings, mediastinum findings, pleural findings, everything that gives us an abnormal score about 0.3 is abnormal. And this is where we have the highest sensitivity. Okay.
Eugene, do we have a question directly related to that? Or? Eugene?
Hello?
Yes,
I can hear you.
Yeah, it's fine. So just my question is, at the beginning of lecture, you told something about how to use this technology to find a biomarker. I'm sorry if I don't understand you, didn't understand you correctly. My question is, did you mean you find new biomarker for some medical problems, or you identify or you find biomarker among other examinations?
Yeah, so going a part of these AI classifiers, biomarkers for us are any parameters that we can measure from the images, no? So for example, as of now, as Erik shown, if you detect the pneumonia lesions like here, in this slide, you can extract the areas, the volume. So we are gathering all that information in the database, because I will show you another environment that we have. So this is the classification of a COVID positive CT. You can see the original image and the attention map. And we decided to provide, actually this is not a biomarker, this is just a score. This is the COVID-19 similarity. We are not saying COVID-19 positive or negative, it's just a similarity, because we say that this CT is similar in a 98% to the CTs of COVID patients. No? But what we want is, once we extract all the features that can be volume, areas, in the same platform, we have embedded not only a patient level analysis, but a population level analysis. And what we have done is to make a kind of quick view of all the database. No? And the database includes, this is an example of radiomics features of another environment of rectal cancer. And basically this allows you to clusterize patients. So you have your patients in rows, and you have your imaging features in columns, and clinical data or associative data in columns as well. So this allows you to perform a clustering. No? Here in this example, we even show the results in a longitudinal basis, no? Where we show the pre-treatment, post-treatment, and we can clusterize the patients according to these longitudinal changes. No? So, I mean, this was what I wanted to show, a quick overview of different functionalities that we are putting together in this Imaging COVID-19 AI project, and where we will build this basic CT infrastructure together with Robovision and the European Society of Medical Imaging Informatics. And I just wanted to finalize saying that this, in the end, wouldn't have been possible without the leadership of Dr. Laurens Topff and Erik Ranschaert, because, I mean, companies, we can make available the technology, we can open our platforms, we can make open repositories, but in the end, we need clinical focus, no, and clinical application. And I think we found the perfect combination here with the willingness of Laurens and Erik trying to move forward this project. And, you know, and we met also Robovision and ourselves, and it was a perfect match because, as you saw from Jonathan's presentation, Robovision has a very, very strong background on you know, performing AI models on the fly, even if, you know, you are not a deep AI expert. And actually in Quibim, we are experts in AI models as well, but also in all the logistics of the images, how to make all the AI models inferencing in real clinical routine. And we have already experience in the integration with hospitals. No?
Ángel, do you want to stop screen share for a second? We can go back
to
video.
I finalized, yes. Okay, thank you.
I got a question from Martin, which I actually brought him here to speak up regarding benchmarks. Martin, would you like to answer? You ask your question?
Yeah, good evening.
Good evening.
I have a question about the validation of the algorithm. Ángel, can you explain a little bit how you are going to validate the algorithm and benchmark perhaps against other diagnostic tools?
Yes, actually, for this project, we have a deep discussion now because in the end, there is quite a significant heterogeneity on the positive or negative cases using RT-PCR. That's happening in Spain today. All the microbiology departments are not as accurate between them in the determination of COVID positive patients or COVID negative. So we will collect around 15 variables in the project. Among them, obviously the results of the RT-PCR and also ICU data. So we have to select the ground truth, right? And the ground truth, in this case, in this project, will be for sure the final diagnosis of COVID, no? And basically, we will test our sensitivity and specificity, accuracy, and all the associated metrics to AI and e-classifier against this ground truth. But ideally, what we will do with the data is we would like to predict other aspects like the prognosis of the patient as well. And also, if we can extract more or less information on the time in ICU and other clinical endpoints. I think that the idea is to identify which clinical endpoints we can get homogeneous data from these 30 hospitals and then create AI models that are targeting these clinical endpoints. Again, not only in diagnosis, that's okay, we have RT-PCR, it's not accurate all the times, it's not homogeneous all the times in all the microbiology departments, that's diagnosis. But then let's work out mortality and prognosis as well. If I'm doing a CT when the patient arrives and I can classify in probable exitus, non-exitus, and then I know I have to rush.
Thanks for answering. We have Sunny Eye Cowboy. Actually, what's your name, your real name?
Yeah, here's Sun from Infovision. Yeah. So just now, I think.
Thank you.
Yeah, just taking this name because I saw a few slides before that might be pointing to me. Yeah, so I think taking this name. Yeah, so actually, like, I have a question. So, let's say, I would like to know how the workflow is constructed when hospitals really want to use the solution. Yeah, and thank you, Ángel, for your presentation. It's a marvelous solution. Yeah.
Oh, thanks, Sam. Very much appreciate it. Yeah. Well, basically, I think that the importance in the project is the whole workflow, no? Not only, I would say, when the model is developed. Right now, we have a workflow of sites registration, and this is already a deep work in the project, to get the approval of the ethics committees. That, thanks God, committees are going very, very fast. Even in the hospitals, I know that usually take more time. Today they were telling me, I mean, if you send us the project, we get a fast track. This is a pandemic, so everyone is concerned in this problem and in this project. So we hope hospitals go all the bureaucratic processes as soon as possible, and we already have hospitals that are already integrated in the platform. So that means already passed all this project approval. And once the project is approved, we install the MUC system, and basically the MUC starts collecting CT cases from the PACS and pushing them to the cloud. So radiologists does not need to perform a manual extraction. And once the data is in the cloud, they can annotate with the clinical data, and they can fill also the clinical data in the MUC if they load an Excel file or any associated file with, for example, the ICU information, the COVID positive, and these things.
Mm-hmm. Yeah.
So
thanks a lot.
Thanks for questions so far. I would suggest the following, because it's 8:30 or nearly 8:30 right now here. So, so to say, to close the official part today. And feel free just to stay here for a second if you have more questions. And I would also welcome your feedback. So you've seen probably my LinkedIn post as well. Comment if you still want to comment, and try to give us feedback and about the projects, about your thoughts, ideas, whatever you think might be interesting for us to share, so that we can facilitate the discussion a little bit longer. It would be very helpful. So far, also a big thank you to the whole team on the panel today. So Erik, Jonathan, and Ángel for joining us and being so open to speak about that cool project. I like it, and can hope you can make it and bring that to success to help us all here in this case. I will end the recording at that point. You can still stay here if you like.